All right, so last unit, we talked about scatter plots. And scatter plots are what we use to show our data, right? We collect data, we want to take a look at it and see what it might be able to tell us. And so determining a relationship is one of those things that a scatter plot might tell us. Now the question is, where does the data come from? And your scatter plot and your trend line and your predictions from a trend line are only as accurate as the data will allow it to be. And so we've got to be careful how we go about getting data. Okay, so that's what today's about. Samples and surveys. How do we collect data properly so that we can be confident in our results from anything that we do with the data? So you should be able to classify data and analyze samples and surveys. So first off, a couple of different types of data that we can collect. One's called quantitative. Quantity means number, how many of something we have. And so quantitative data is data that measures quantity and can be described numerically. Another way to look at this is it makes sense to find the average. If it makes sense to find the average, then it's a quantitative variable. Now, examples of quantitative data, right, is if we wanted to know the price of people's cell phones, or how many video games, or how much in video game sales the store has, or someone's age, height, the time it takes to do something, or the cost of downloads, right? All that stuff makes enough sense to find the average. Now, if you're working with a variable where it doesn't make sense to find an average, then that variable is called a qualitative variable. Another word for qualitative would be categorical, because it places individuals in categories. Things like birth month, favorite clothing brand, type of pizza, hair color, eye color, right? Eye color. Do you have blue eyes, brown eyes, green eyes, hazel eyes, right? It doesn't make sense to find the average of colors. Zip code. Now, zip code's kind of weird because zip code's a number, right? But just because a variable is expressed with numbers, it doesn't make it a quantitative variable. Zip code. 2 zip codes in Greenwood, 46142 and 46143. And it doesn't make sense to take the average zip code. Okay, so with qualitative, it does not make sense to find the average. All right. So let's try it out. Some examples here. Are these quantitative or qualitative? So if you want to grab a bunch of individuals and find out who their favorite author is, right? Favorite author, does it make sense to find the average of authors' names? Well, no, so that's going to be qualitative, right? What about today's temperature? If you take the temperature throughout the day, does it make sense to find the average temperature? Sure, so it's quantitative. Savings account balance, what do you think? Does it make sense to talk about your average savings account balance through the month? Okay, hopefully yes, because that's exactly how you get paid interest. So that's quantitative. Gas mileage, average gas mileage, makes sense? Sure. Excuse me. So that's quantitative. What about brand of your shoes? Okay, it doesn't make sense to find the average of Nike, Adidas, Reebok. So that's going to be qualitative. Okay? Good. Now, as you're collecting data, your data sets might be univariate or bivariate. Univariate, uni meaning one. And so what that means is you're going to grab a bunch of individuals and measure one variable. That's it, right? So if I wanted to know the average, if I wanted to find the heights of the students in Center Grove High School, right, then that would be univariate. I'm just going to grab everybody and measure their height. If I wanted to know about handspan and height, if there's a relationship between handspan and height, then that would be bivariate. I would grab everybody and measure their handspan and their height. So you're going to measure two variables. So you're going to measure two variables. Okay, so that's the difference between univariate and bivariate. Scatter plots we use with bivariate data sets because there's two variables, right? We can plot one on the x-axis and one on the y-axis. Univariate, we usually use stem plots, dot plots, histograms. Those are all things that you've probably seen at some point in your life. Univariate, some examples: number of movies watched, distance ran, cost of cell phone plans, number of relatives. Bivariate, if you want to know the number of boys and girls in the class, if you want to know the length and width of fish caught, or the number of movies and TV shows downloaded, that would all be bivariate. Okay? Now, as we're collecting data, you've got to consider whether we're collecting data on a population or on a sample. And so a population is the entire group you're collecting information about. Now, the population doesn't mean, especially if you're talking about humans, it doesn't mean everybody everywhere necessarily. If I want to know who the state of Indiana is going to vote for president, then the population of interest would be just the residents in Indiana, right? If I wanted to know who the country was going to vote for, then the population would be all the registered voters or eligible voters in the United States. Okay? Now, a sample is just a very small part of that population. We're just going to talk to a very small handful of the population. Okay? Now, samples. Why do we even talk about samples? If we're going to collect data, we might as well collect data on everybody, right? The entire population. The problem is that would be very, very costly and take a very, very long time. If we talk to the entire population, then we're taking what's called a census. And in the United States, we do actually take a census of everyone every 10 years. Right? And so we knock on doors and count everybody. But that, again, like I said, it would take too long. Very often it's going to take too long and cost a bunch of money. So what we do in statistics is we take a sample and we allow a small sample to tell us what we need to know about the population. There's a science behind that. So when you're going to just take a sample of a population, you have to be careful how you do that. You need to choose a sample that would be representative of the population. You need everyone to have the same chance of being chosen. And hopefully it gives us a group that mirrors the population. And so the first method for choosing a sample is called a random sample. It's a simple random sample. Okay? And so basically what you would do, if I wanted to know the height and handspan of every student in Center Grove High School, then I wouldn't go or use data, right, or try to, I don't know, predict the height of a student coming in from their handspan, right? So then I would want to collect heights and handspans of students here and use those heights and handspans to make a prediction. Now, I'm not going to talk to everybody. I'm not going to find everybody. It's going to take too long, right? So what I would do is I would put everybody's name on a piece of paper, drop all the names in a hat, shake the hat up, and then start pulling names at random. That way everybody has the same chance of being chosen, but we're going to do so randomly. I don't get to pick and choose. Okay? That's the most basic form of taking a random sample from a population. Just put everybody's name in a hat, shake the hat up, and then start pulling names at random. Okay? But there are issues there, right, with random samples. With random samples, it's entirely possible that you get all of your sample is from or has similarities in some way. Right? What I mean is, if I randomly choose students from Center Grove High School to measure their handspan and height, is it possible that my entire sample contains the tallest people in the building or the shortest people in the building? The answer is yes. So while we hope it gives us a representative sample of the population, it may not. There's a chance that it doesn't. Okay, systematic is another sampling method where we number everybody and then randomly choose a number, select a number at random, say in this example 9, and so every 9th person would be chosen for our survey or for our study. Okay, again, we hope that every 9th person would be a pretty good representation of the population, but there's no guarantee there. But that's called systematic. It's a systematic method. We're systematically choosing. Okay? And then the best way to assure that your sample is going to be a representation of your population is to take a stratified random sample. And so what we would do there is we would group our population into different what are called strata. So group our population into strata, and the strata are all going to contain people that are a little bit or have the same characteristic. For example, if I want to know how the students at Center Grove High School feel about Mr. Bird as a principal, I know that that might be different depending on what grade you're in. So to make sure that, and so in a random sample, I know it's possible that my sample may all be of freshmen, because I'm just going to put everybody's name in a hat and start drawing names out. I can get all freshmen. So to avoid doing that, I would create strata. And strata, I would create strata based on grades. I would separate you guys into freshmen, sophomores, juniors, seniors, and then I would random sample from every group. So take a few freshmen, take a few sophomores, take a few juniors, take a few seniors, and then make that my random sample. That way I know the entire population is evenly represented. Okay? Now, here are a couple of videos to help illustrate these differences.
A major winter storm losing fights and win Tuesday's Republican most dangerous fire response.
With your help, we're going to win a historic victory.
The 2012 presidential campaign is in full swing, with Republican candidates battling state by state to determine who will face President Barack Obama on Election Day.
In the poll numbers we are debuting tonight, there is a new GOP frontrunner in this race.
A crucial part of this grueling electoral process is polls, the almost daily snapshots of public opinion that help measure who's up and who's down among the candidates.
The aim of an opinion poll is to get a sense about a population and where they stand on some particular set of issues or policies, to measure their attitudes in effect.
Vincent Hutchins, an NSF-funded professor of political science at the University of Michigan, says that public opinion polls rely on a concept in statistics known as random sampling. The idea that it is possible to draw a clear picture about the feelings of a large group of people by examining how a small, randomly assembled slice of that group feels.
The process involves interviewing a very small subset of that population and doing so in a scientific manner, so that you will have a better, accurate sense, but more efficient sense of what the entire population understands.
An opinion poll might focus on a particular state, such as Florida, or the entire U.S. population of more than 300 million people. Pollsters use computer programs to generate a random list of a few hundred or a few thousand telephone numbers from the larger group, and then they call each number to survey people for their opinions. Hutchings says making a random sample is a lot like cooking soup. You don't need to eat the whole pot to know if it tastes good, you just need a spoonful.
The cook merely needs to get a spoon out, taste it. That spoon represents a sample, as it were, of the actual contents of the pot.
Samples in general give better poll results when they include more characteristics of the whole population and in the same proportions as the population. Back to the soup analogy, if you're cooking chicken soup, you want your sample to include the ingredients such as chicken, noodles, and broth in the same proportions as the overall soup.
We want to make sure that the sample has the population characteristics that are demonstrated in the larger population to which we want to make an inference.
When reading a poll, it's important to also study the fine print, usually at the bottom. You'll find information there about how the poll was conducted and what the size of the random sample was. You will also find the margin of error, a number with a plus or minus sign in front of it. This number tells you the range of accuracy of the poll. In this case, 3 to 5 percentage points. Typically, the smaller the margin of error, the more accurate the poll is.
What that means is that the number that's reported in that survey, we have a sense that given the size of the sample and given the level of uncertainty associated with that size, the number could be 3 to 5 percentage points higher or lower, but we know it's in that range.
Even though the polls rely on just a slice of the population to gauge public opinion, they are far more accurate than you might think. Which is one reason why they play such a special role in politics.
Public opinion polls provide us with a way, absent an actual election, to discern where the public stands on various issues.
As Election Day 2012 draws closer, the science of public opinion polls will help give a clear snapshot of who might be our next president.
Okay. So an idea, again, of what we're talking about with random sampling. Okay. Now, the different types of sampling. A little more in-depth explanation comes from this video.
Sampling: simple, convenience, systematic, cluster, and stratified. To find things out about a population of interest, it is common practice to take a sample. A sample is a selection of objects or observations taken from the population of interest. For example, a population might be all apples in an orchard at a given time. We wish to know how big the apples are. We can't measure all of them, so we take a sample of some of them and measure them. The method chosen for taking the sample depends on the nature of the population and the resources available in terms of time and money. The ideal is for each object in the population to be equally likely to be chosen as part of the sample. This is called an unbiased sample. It is also desirable for the sample to be representative of the population. If the population of apples were 2/3 red and 1/3 green, the sample should be similarly split. Note that no matter what we do, there will always be sampling error or variation due to sampling, as we are looking at a part of the population, not the whole population. The video on variation covers these concepts more thoroughly. This video presents 5 methods of sampling: simple random sampling, convenient sampling, systematic sampling, cluster sampling, and stratified sampling. For each method, we will outline the process and the advantages and disadvantages. Simple random sample. Simple random sampling is theoretically the ideal method of sampling. You list each member of the population and use random numbers to decide which objects are in the sample. Each object is equally likely to be selected. This produces an unbiased sample, which we hope is representative. However, it can be difficult and expensive to take a simple random sample when dealing with people. Simple random sampling is more practical when the population is geographically concentrated and when a good sampling frame exists. A sampling frame is a list of all the people or objects in the population of interest. Simple random sampling can be more easily implemented for natural and manufacturing populations. Convenient sample. Convenient sampling is just that, convenient. You ask people nearby or people who walk past at a shopping mall, or you take the next 20 objects off the production line. You do what is easy or convenient. Convenient samples are often biased in some way, but for a quick and cheap poll it may not really matter. Convenient samples can also have self-selection bias when people choose to participate because they have an interest in the issue in question. Systematic sampling. With systematic sampling, you choose a starting point at random and then systematically take objects at a certain number apart. For example, if there are 1,000 in the population and you want a sample of 50, you would take every 20th object. Systematic samples are easier to administer than simple random samples and are usually a good approximation of a random sample. However, if there is a pattern in the population, certain types of objects could be chosen more or less often than others. Cluster sampling. In cluster sampling, the population is divided into clusters which are then chosen at random. For example, departments of a business can be clusters, or suburbs within a city. Within each cluster, all of the objects are included in the sample. Cluster sampling can be more convenient and practical than simple random sampling. However, if the clusters are different from each other with regard to the elements we are measuring, it can lead to bias or non-representativeness. Stratified sampling. Stratified sampling seems like cluster sampling, but the strata or groups are chosen specifically to represent different characteristics within the population, such as ethnicity, location, age, or occupation. Within each group, a random sample is taken, sometimes in proportion to the size of the group. Stratified sampling can lead to a very good random representative sample. However, it can be complex to administer, and a sampling frame with considerable information about the population is required. There are other sampling methods. The 5 explained here give an idea of the advantages and disadvantages of various methods. You should attempt to use the sampling method that produces the best result for the resources you have available. If your sample has known bias, this should be taken into account in analysis and reporting.
Okay, and so there you go. Again, just a couple of different ways of getting a more in-depth explanation there. So hopefully that makes the sampling methods make sense. Now, the last video did mention something called bias. And when you sample poorly, if your sampling method is done incorrectly or poorly, then you get what's called bias. And bias is an error that causes one option to seem better than another. Right, so in the example here is, and again this is perfect, it's an election year. If a pollster phones every 4th registered Democrat in the state to find out which candidate for senator the person prefers. Well, since they're calling all Democrats, then obviously their results are going to say that the state prefers the Democratic candidate instead of the Republican or the Independent or the Tea Party or whatever. So that's going to introduce bias. You're going to get more answers towards the Democrat than is going to be representative of the population because you're only calling Democrats. Okay? And so you want to avoid that. You want to avoid choosing a sampling method or listening to a survey that has a sampling method that is sort of geared toward giving one answer more than another. And you have to be careful of that. Okay? So, a couple of examples here. Determine whether the sampling method is random, systematic, or stratified, and then tell whether the method will produce a good sample. So, if you're a bottle manufacturer and you check the quality of every 3rd bottle that you make, what kind of sampling method is that? Think about that for a second. Okay, and is that going to give you a good sample? Well, hopefully you realize that's a systematic sampling method, right? You're choosing every third one, and, you know, there's no reason to believe that every third bottle is going to be drastically different from the population, so it should be a good sample. Okay? What about a printing company randomly selecting 10 of 450 books it printed to see if all the books were printed properly? Okay, what kind of method, what kind of sampling method is that? And is it going to give you a good sample? Right, well, this is going to be a random sample, and it should give you a good sample, right? Choosing 10 of 450 books should give you a pretty good idea of whether the books were printed properly or not. Okay? What if you choose every seventh student whose driver's license ends in odd number is asked to complete a survey on safe driving habits? Okay? That sampling method is systematic. And while not everyone is equally likely to be chosen, as long as you understand that you're just choosing people whose driver's licenses end in an odd number, then it should be a representative sample. There shouldn't be anything wrong with the sample. Every seventh student shouldn't, probably more than likely will not give you a particular answer more often than not on safe driving habits. Okay. Lastly, you randomly ask 15 residents on your street whether they support the local bond issue, which means they're going to pay taxes to build a community center across town. And consider a huge town like Indianapolis, right? So you randomly ask 15 residents on your street if they support a local bond issue, which would affect you, to build a community center in Carmel, right? So what do you think? It is a simple random sample. Actually, it is a random sample, but since you're choosing from your street, the people on your street are going to be alike in some way. And so that's going to be a stratified sample. And no, this is not going to be representative because you're going to get a whole lot more people saying they don't support it because the community center is so far away. They're not going to be able to use it, right? So there's some examples of good and bad samples and the different type of different sampling methods there. Okay? All right, that's it. Give that a shot. Homework's out in Canvas. Have that done next time.